All right, cool. Well, thanks, Chris. And good morning, everyone. Again, my name is Russ Ropkin with RSI Company. I've been doing programming in the automation industry for a very long time, 30 plus years now. Specifically, IEC 61131 programming. I also provide Iconics integration work and training as well over the years, and worked in lots of industries over the years as well, mainly water, wastewater these days. I also do some oil and gas work, building automation as well. So that's pretty much me. And RSI Company is a small company. It's just myself and my wife, and we try to focus on helping our customers and making sure that they have the best product anyway. Now, today I want to talk about working with text files and CODESYS. And I should start off with, I'm not here to really promote anything. I just want to spread some knowledge, and I always learn some things in these presentations as well. But I learned about reading and writing text files when I was helping out an OEM actually a few years ago. This OEM had an application where they needed to configure a Modbus slave in their controller that was running CODESYS, and it needed to be dynamic. They needed the customer to be able to configure which tags were tied into that Modbus slave, and a whole bunch of other settings that they needed to do. So they approached me to help them with it. They actually brought in somebody else to write the user interface, which they did in Windows itself. But ultimately, that user interface sent a text file to the controller. The controller then read that text file and configured the Modbus slave accordingly based on those settings. So, and it was a fun project. I learned a lot about working with text files and CODESYS and how that works. So that was my introduction to it anyway. And then after I did that, I realized how much more I could do with these text files. And I had another client that needed a use for recipes. And we'll talk about that just a little bit more because that's specifically what I'm going to cover in this presentation. But, you know, why else would you need to read and write text files in CODESYS? And of course, there's lots of reasons, and definitely some I'm sure I haven't even thought about. But that application configuration file, as I was mentioning, is certainly one. Recipes, data storage. If you need to temporarily store some information in a file, this is a great way to do it. Event logging, even troubleshooting. You know, being able to write out some information from the controller. Like I said, lots and lots of applications for this. And it's really, really powerful as well once you dive into it. Now, to work with text files, the sys file library is where you'll find all of the functions and function blocks, enumeration structures that you need to work with the text file. And I've just listed here a few of the ones that I've used on a regular basis, such as opening a file, reading a file, of course, writing a file as well. And the documentation is really good on this library, by the way. If you jump in and look at each one of these, it explains it really well. The gist of it, though, is you open a file and you receive a handle to that file. Once you have that handle, you can read it, write to it, get all kinds of information about the file as well. For instance, getting the size of a file. Oops. getting the current date and time on the file. You can copy and delete files as well. Pretty much anything you'd need to do with a text file it can be found in this sys file library. So that's where I spend most of my time anyway. Learning about these text files was in this sys file library. Now, let's talk specifically about the recipe manager that I'm going to show you in a live demo here in a minute. And I should start off with CODESYS does have a very good built-in recipe manager, and you can add that to any object you want. In the right-click menu, go to Add Object, Recipe Manager. And I have used that recipe manager in the past in applications, and it works really well. However, this particular recipe manager, the client needed more flexibility. They wanted to be able to create these recipes outside of CODESYS and then push those recipe files to the controller and have the controller recognize them and be able to read data from the recipes as well as write data out to those recipes. So this particular recipe manager has a really minimal user interface. Most of the interaction is within the files outside of the controller. The file itself is a simple text file, and I'll show you an example of one here in a minute. Really just a comma-separated file that has the tag name and, of course, a value stored in it. In addition to that, there's also some settings in the file as well that help set up the recipe itself. One of the key features they wanted was automatic folder monitoring. So in a folder in the controller, if somebody placed a new recipe file in there, they wanted the controller to be able to recognize that, hey, there's a new recipe file, and I need to do something with that file. I need to either read it, or maybe it's an empty file that just has tags in it. And in that case, I might need to update the values and write that text file out. So they wanted to be able to monitor those recipes and then automatically handle them when they showed up in that folder. Now, beyond that, we, of course, need to be able to read those recipes, and that can be optionally either automatic or manually from an operator. So through a SCADA system, they could have a button that says, hey, read this recipe now, things like that. Same with writing, optionally automatic, maybe on a time-based interval, something like that, as well as manually from an operator to be able to write that value or write that recipe anyway on demand. Now, probably the most challenging part of this was the variables. So all of the variables that are in the recipe, they do have to be exposed in the symbol configuration. So in order to use this particular recipe manager, it only has access to variables that are in the symbol configuration. And I'm not going to spend a whole lot of time on that side of the code. In fact, that might be a really good topic for a future tech talk, actually. But I will show it to you and kind of explain how it works. But there is a way in the code to read the symbol configuration and find variables. And I use that to be able to look up any variables that are in my recipe and find them in the symbol configuration, which of course then gives me a handle to that variable and I know what type it is, as well as getting a link to the data itself for that variable. So it was critical that the symbol configuration has to be configured and those variables have to be exposed in that symbol configuration for the recipe manager. All right, what did I miss? I think we're good. Now, real quick, here's an example of a recipe file. As I said, really simple, comma separated. Anything that starts with an asterisk is a configuration item for this particular recipe. So it has a name, has a version. Honestly, haven't used that version for anything yet, but maybe in the future. has a date to the last time it was written to. There's an enable, of course, to enable or disable the recipe, and then a few other settings, whether it's monitored in the file structure or periodic writing is enabled as well. Now, once you get past all of those settings, it is literally tag name, comma, variable. So in this case, I have some flow variables from a pump station that I'm going to show you. But I'm just reading those flow values and writing it out to the recipe. Recipe ends with an into file at the end of it. So like I said, really simple, really easy to create these files and be able to read and write those in the recipe manager. Now, lastly, we'll jump over to the lab demo and we'll bring this up and show it to you. This is just a screenshot of it, but let's jump over to the actual demo here. Now, this is a simple pump station that I put together a long time ago for training purposes, really. And it's all simulated, has 3 pumps, 2 tanks. You can say we have a source tank on the left, going to another tank on the right. And when the tank on the left reaches at this, in this case, 18 feet, then the pumps automatically start, and then they push water over to the other tank until it reaches 8 feet, and then the pumps stop. So a really simple little algorithm, but it has a lot of good stuff in it that I often use for testing when I'm playing around with things. And so, of course, I use that for my recipes as well to test this out. There is one pump, by the way, that I have in manual right now, just so I always have one pump running. But of course, you can start and stop those pumps if you wanted to. Let's see if that guy will stop. Of course, it's going to act up on me when I go to do that. My bad. All right. So we'll shut down a pump just for the heck of it. Now, as I said in the presentation, the recipes themselves have a pretty simple user interface, and that's on this recipes tab here. At this point in time, I have 3 recipes enabled. The recipe manager right now anyway supports up to 16 recipes. And that was honestly an arbitrary number. But it did kind of help with memory, you know. Obviously, the more recipes you add, the more data you're going to take up. So anyway, up to 16 at this point, and 3 of those are enabled right now. And in this window, I hope you guys can see that okay on the other side. It may not be terribly big, but there's 3 different types of recipes here that have different settings. The first one I call the flow report. This one is periodically writing to the recipe, and right now I have it set to 60 seconds. So once a minute, it reads these values and writes them out to that recipe file. And that's really its only job. Read some values, write out to that text file. Excuse me. Let's start our pump back up so we get some good numbers going here. Now, the second one is called the start stop set point recipe. It's reading 2 values, and they happen to be those start stop values that you saw over here, my 18 and 8 feet here. This particular recipe is enabled. It does not automatically monitor anything, so it's only controlled specifically from an operator. So manually, you would manually update this file and read it or save it. And I'll show you that in a minute. We'll modify that file and push it in here and watch it do its thing. The last file is it's only setting 1 value. It happens to be the flow set point for pump 3. This particular one, though, I have set up to monitor the file. You can see the checkbox here, monitor file. So I'm actually watching that file. And if the date and timestamp changes on the file, then I will read the recipe and update the value accordingly for that particular item. So basically 3 different types of recipes in this case. And then the last point I wanted to make was, when we talked about this during the presentation, this recipe manager also has to monitor for any new recipes that show up in the folder. So I think we'll actually start with that. I have another recipe ready to go. I'm just going to use the built-in file manager in CODESYS, but obviously depending on your hardware, this happens to be a Raspberry Pi, by the way, just for testing. But depending on what kind of hardware you have, you may have many ways to get files into that controller. Depending on the base operating system, obviously if it happens to be Linux, you'd have all kinds of ways to get files in there. And some of the controllers, such as Opto22, have a built-in file manager in their configuration tools as well. So lots of ways to get files in and out of there. But for demonstration purposes, I'm going to stick with this just file manager that's built in here. Now I created a folder called RSI. Underneath there is my recipes. And as you can see, there's those 3 recipe files that we were just looking at the configuration on for those 3 recipes. Now, if I remember where my other recipes are, which are in the project folder, let me go grab those. And I should have had this all set up. My apologies. Let's see. Should be in here. All right. So I also have right here pump1.flow.setpoint.rcp. So that's another recipe file. If we look at that file real quick, it again has a single tag in it right there. And it is going to change the flow set point for pump 1 to 9,000. Now, before we push this in, let's take a look at pump 1. Its current flow set point is 7,500. And why don't we just get these things running real quick so we can see it changing too. So I'll just fake in my my settings here and get that pump to start up. There we go. As you can see, pump 1 and 2 are starting up since they're in auto mode. And we should jump up to about 7,500. And by the way, the PIDs are not tuned very well in this simulation, so you'll see them hunt around a little bit. But that's okay. All right, that's going to settle in at 7,500. Now, if I go back to my files and I grab pump 1, we'll push it over there. There we go. We drop pump 1 in the folder. And if I jump over here, it's already happened. We take a look at our flow set point. We're at 9,000. And if we jump over to recipes, you should see a 4th recipe show up. There it is, pump 1 flow set point. And of course, it has my my 1 item in that recipe with the flow set point set to 9,000. So as I said, up to 16 of these. And again, you drop the file in there, it recognizes it, reads it, and away you go with your recipe. Now, to show you that a little differently, here's our start stop set points, right? We have 18 and 8 here. I jump over to that one and start stop set point. As you can see, the file here on my machine, they're set to 20 for the start and 5 for the stop. So I'll just make sure that's saved. Jump back over here and we'll push that recipe over and overwrite the existing one. Now, as I mentioned earlier, this one's not monitored. So we push the new file there. As soon as I hit the read, it should read that file and you should see your values get updated. Like I said, should. Obviously, I messed something up there, of course. Let's jump back over here. I did save this, right? You know, you test these things over and over and over again. And when you get to presenting them, that always happens, doesn't it? All right. Yeah, I definitely didn't update because you can see the time was wrong on it. That's interesting. No, the time's off on my controller. That's the whole problem. All right. Let's see if it manages to read it, though. Here we go. So found my file, read my values, and of course, if I jump back over here, I should have my 20 feet and 5 feet accordingly. So that's the general idea, right? It's a pretty simple idea, is read and write recipes. And let's see, we have about 15-20 minutes left. So I do want to talk a little bit about the code and show you guys how we accomplish this and put this together, and hopefully you guys get some ideas out of this, and hopefully somebody can use this down the road. Because again, that's my whole idea, is to just kind of put out some ideas and kind of jog your mind and kind of think about how you guys might use this in some of your applications. One thing I did not mention was the folder where I place these files. That is most definitely going to be device dependent, and it all depends on how that particular manufacturer implemented CODESYS, and what areas of the underlying operating system they give you access to. So in the case of the Raspberry Pi, you have access to the main CODESYS folder. And I believe there are ways to get access to other areas. I just haven't experimented with it myself. But in any case, that's where I ended up plopping my files, was creating an RSI folder there, and then adding my recipes folder as well. But you will have to experiment with that on each individual operating system. I have run this on a Wago PLC and had no issues with that. I've also tested it on Opto22, both the Epic and the Rio now as well. And it works great. And they have built-in tools to help you get the correct permissions to those folders and things like that. But that is something, if you go down this road, you'll have to work on, depending on the device that you're working with, where those files can be stored and how you can access those files. So meant to bring that up earlier. All right, now let's take a look at this a little closer. I have a couple different user-defined types. First of all is the recipe manager itself. And it's a pretty simple DUT to start off with. There's really just an init, and all that does is initially on startup anyway, clears out all the recipes and then reads the folder on startup. The index I simply use for iterating through the recipes, and then I have a recipe count just to tell me how many recipes have been found in the folder. Lastly is just an array of another data type of recipe storage, which we'll look at in a minute. And as you can see, it's just an array 0 to a max recipe count, which I currently have set at 16. So that sets up my recipe storage. Now, I implement this data type in a global variable list called controller. As you can see right here, it's called recipes, and that's where I implement that. To put that to use is really pretty straightforward. I have a main program that I called main symbols. And as you can see, I have a separate task that I built specifically for that. And it simply calls a subroutine called recipe manager, and it passes to it my DUT called recipes. It does have a built-in way to pause it as well. If you ever needed to pause the recipe manager, you could add an extra tag in there to pause that. But it's pretty much that simple. You call that recipe manager. And of course, if I jump over to that, this will, there's some initialization stuff. Like I said before, it initializes. Every time index gets back to 0, I reinitialize, by the way. That's how I recognize files coming in. So I go through each file in the folder. When I get back to the beginning, I look for new files. So after each iteration of all the files, we look for a new file and pull that in. Now, as I iterate through, I call another subroutine called recipe storage and pass to it the particular recipe that I'm working on at that particular time. And then, of course, down at the bottom, I'm just incrementing. And once I hit my max recipe count, I reset it back to 0 and start over again. So I'm really just iterating through looking at each particular recipe. Now, if we look at the recipe object itself, a little more involved here, but the main pieces are those settings that we found in the file. If you remember, we had version, name, date enabled. So those all get read from the file itself. Then, of course, we have a file name that we set once we read it. The strings itself, I'll show you guys that in a minute. So when I read the file, I read it one line at a time, and I push it into an array. There are certainly multiple ways to do this, but this worked out good for me in this application. So I created an array of strings, and then the file itself, of course, has an end of line character on it, carriage return line feed. So when I read that file, I can break it up into lines and then push that into an array. So that file ultimately shows up an array of strings in my system. And then beyond that, there's a few other settings for being able to manually save or manually read the particular file, number of items that are in the file. And then after I read the file, I do put the individual items that I find in the file in their own array as well. And that's a pretty simple DUT if we take a look at that real quick. It is literally just item name and item value, both strings that I'm reading from that text file. Now, I had one more item visible, and that's simply used for the visualization, by the way. So I turn that on and off as to whether it found that particular recipe or not, so that I could display it or hide it on visualization. Beyond that, the rest of this stuff is monitoring. If I have an error when reading or writing, I put all of that in these two items so that we can generate errors or let us know what happened there if something went wrong. And then my monitoring, which is really just a timer that I sit and every now and then I look and see if that recipe has changed or not based on the date and time, and if I need to read that or not. And then lastly is one more timer for the periodic write. So if I'm periodically writing that value out, that timer handles that part. So nothing too crazy there. Now, as I said, the recipe manager is just iterating through these, right? And calling recipe storage. So we jump over to that. That's where the meat of all of this happens. You will see, by the way, that I like to write in structured text. So that's my my language of choice anyway. Let's see if we can zoom this in just a little bit for everyone. Hopefully you can see that a little bit better. Now, remember, this is getting called for each recipe that it finds. And of course, we are passing in the recipe and all of its settings and all of its information. So, to begin with, if it's time to save the file, then we take care of that. If it's time to read the file, then we take care of that by calling read recipe. And we'll take a look at those here in a minute. And then the rest of this is all that monitoring stuff. So if monitor's enabled, I'm running a cycle time call here to see how long it's been since the last time I looked at that file. And if monitor is enabled, then I'll look at how long it's been since I've checked it. And if that check is larger than some monitor interval, then I'll go out and I'll check the file time. And if the file is changed, then I simply turn on the read bit right there. And then the next time around, it'll read that file. Now the periodic write is below that. So, and that again is just a simple timer. I call that timer. That timer expires, then I turn on the save bit. And then again, the next time around, it'll save that file. Now, the meat of this, I think that you guys really want to see is the text file stuff, right? So let's jump over to that. And again, we'll zoom this in a little bit. There we go. So as I mentioned in the presentation, the sys file library is where you'll find all of this, all of these functions and function blocks. And the very first thing you always do with a text file is open it. And you can open it for read, or you can open it for write. And there's one other option there, which I don't remember off the top of my head, but we might be able to jump over there real quick. Yeah, I went to the wrong place. In any case, there's a couple options there for the access mode, read or write being the main two. In this case, I'm reading the file and really just making sure it exists. So I open up the file, and if I get a valid handle, then I know that file exists, and I'm good to go and I can move forward. If it's not valid, then I'm just going to jump out of here and get out because something happened with that particular file. It doesn't exist anymore. Then beyond that, we start reading the file. So we find out how big it is. We clear out the current file strings in our DUT. And then we read it. And that's all done in this while loop. As I said earlier, at least my choice for this particular application was to read those files by individual lines and then put those lines in an array. So that's what this while loop does, as it goes through the entire file and reads each individual line. You'll see right here, I'm looking for end of string. And end of string just figures out where that end of line file is, that line return right here. Let's jump over to this real quick. So there's my end of line string, which again is carriers return line feed for for that particular string. I was in the wrong spot. There we go. Read recipe. So that's what we're doing here. Reading the file, grabbing each line, dumping that into an array. So the end goal here with this particular function that I'm calling, of course, is to set the file strings in this particular DUT. Now, once I've read those file strings, go back to recipe storage, and we set all of the individual settings in the recipe, and we read each variable, and we read the value for that particular variable if we need to. All right, and that's actually done at this particular level here. Okay, there it is right there. Sorry, read data from recipe. So now this is where we get into reading variables from the symbol. So I'm going to jump over here, read data from recipe. Now, so we know because we put all of these file strings in an array, we know how big the file is, and then we can go through each line and look at that particular line. First thing we do, if you remember, I said I started any settings with an asterisk. So the first thing I do is I look for that asterisk. If I find that, then I know that that particular line is a setting. So I'll go through, find each setting, and set those values. Once I get through that, if I know it's not a setting, then I know that it must be a variable. So I look for my delimiter, which of course is a comma, right? I look for that comma, and then I separate that string into item name and item value. And that way I now have the variable name that I'm looking for. And if there happens to be a value there in the recipe, I have the particular value for that item. Now, once I have that information, I can go through each item in that recipe in a for loop here, and I can find that symbol using that symbol utility. And then I can set the value, depends on what I'm doing, whether I'm reading or writing it, right? I can either set the value or I can set the value in the recipe from that particular item. Now, this is that section I was talking about that requires the symbol access. And to be straightforward, I'm not completely proud of this this code, but it does work. And I am currently looking at another way to implement this. So the way the symbol bar access works is you can actually browse your symbol configuration. I don't know if you guys have ever, or for those of you that have set up, say, OPC UA or CODESYS Access, the symbol configuration is where you configure which items are available for external access, right? So here's my particular pump station that I have and all of the variables that are available. And of course, you provide a check mark for each item that you want to be available. Well, from code, you can actually browse this symbol configuration and look for a particular variable. That process is not particularly fast. So rather than browsing for each variable every time I need to get to it, what I did was I buffered it. So I went through the entire symbol configuration and I created an array of variables and all of their particular information, and I stored that. So on startup, anytime we finish starting, you can see I initialize my symbol utility, or anytime there's an online change, I will also initialize my symbol utility. So it'll go through all of those symbols, find them, put them in a big array. Now, the reason I say I'm not terribly proud of this is because I want to show you, if I view my memory usage, you can see my symbol utility is a big chunk of memory that it takes up in my controller. And that's because I have to plan for a very large program, right? And be able to store a lot of information. Now, I've recently started looking into dynamic memory allocation, and I think that would help a ton with this. So I'm going to start looking at that. I'm also looking at ways to find those symbols a little bit quicker so that I don't have to store them all the time. Now, in any case, that does work out pretty well. I store them in that array, and I can very quickly look them up, find the particular variable I'm looking for, and either get the value or write the value to that symbol. And that's kind of the whole end goal there. All right. Well, hopefully I didn't cause more questions and confuse too many people, but that was, really my whole goal here was to give you guys a look at how you might be able to access text files, read or write them, and hopefully you guys find a way to use those in your own application, because it really has worked out well for my particular clients, specifically with this recipe manager anyway. So, Chris, I think that's it. Take